Welcome back, everyone, to McCall Science Enrichment, and today's experiment is entitled Cranberry Chemistry. Now, today's materials come from a household kitchen, or at least a household, and it just goes to show that kitchen science is where science really happens in the household. These are materials that you probably do have on hand at home. Some are safe, some are a little bit more dangerous, and let's review those materials right now. For this experiment, you will need one bag of fresh cranberries. This bag of cranberries was purchased, way back in late January, right after the winter holidays. These are fresh cranberries, they're whole berries, and they're all set to go. For this experiment today, we're going to be using one lemon. This is a rather old, rusty looking lemon here, but even though it's sort of soft and kind of getting discolored, it should be just fine for this particular experiment. You will need one box of baking soda. This came from my refrigerator. It absorbs odors and it's doing a great job there, and I'm sure it'll do a great job for this particular experiment. You will need a spoon, our good old spoon. You will need at least one clear glass. I'm going to be using shorter glasses today, and as long as you can see easily inside that glass, then that's a good glass to use for this particular experiment. You will need some kind of a pourable container. This is one of my Pyrex measuring cups, and I have my pour spout right here. You will need a strainer. This is a metal mesh strainer that I use to make iced tea in the summer, and that's all ready to go. And the last liquid ingredient for today is this stuff. This is ammonia. Now, ammonia looks innocent, and it's found in most households as a cleaning supply, but this stuff is very, very dangerous because the odor, the fumes, the smell that comes from ammonia can actually damage the inside of your nose in close quarters. So if you're in a room that doesn't have much ventilation or airflow, be very, very careful of ammonia. This stuff is dangerous, dangerous, dangerous. So make sure that you have an adult handy when you use this stuff at home. You also need some cold water, which I have now inside the top part of a blender. Now notice, blenders use these very sharp metal blades here. Make sure that you're always using a blender, an electric appliance with an adult. These blades can be very, very dangerous, and I've already got my water inside this blender container. So those are the materials for this particular experiment. Let's move on to our step-by-step procedures. Hang on. The first step for this experiment is to empty the whole bag of whole cranberries into the water that's inside the blender. Now, once those cranberries are in, you notice that the water isn't quite covering them, so I do plan on adding just a little bit more water to cover all of those cranberries. And notice, those cranberries are floating in that water. That means that the cranberries are less dense than water. They're floating up. And that's good because cranberries grown in America are harvested in either one of two ways. They're either harvested in a bog, sort of a marshy, wet area, by the wet method, or they're also harvested by what's called the dry method. Now, these whole cranberries that we saw in the bag earlier are harvested by what's called the dry method. The dry method involves the cranberries growing throughout the year. These cranberries are on nice green tender plants, and the goal of the dry method is to keep the cranberries as beautiful as possible. So whole berries that are sold in a store like this are harvested by the dry method. In the dry method, when it comes time to harvest these red berries, a machine is used to pluck these berries very gently from the plants themselves. And then they're sold in the store at a premium, and they look beautiful and they're delicious and all that kind of stuff. Now, there is another method that's used to harvest cranberries, and that's called the wet method. And with the wet method, the entire field of cranberries is flooded with water. And you can see a picture here of these workers that are using tools to harvest and gather these cranberries together. Once the field is flooded with water, cranberries will float, just like you see them floating here in this blender. And it just so happens that this method is really, really effective because if you cut open any cranberry, on the inside you can see that a cranberry has 4 air chambers inside, and that allows these cranberries to float in water. It's these air inside these 4 air chambers that allows these berries to float in water. And once they float, they can be gathered together and harvested. The only bad side to the wet method is that it sort of damages the berries. So the wet method is used for berries that are going to be crushed and used for juice and cranberry sauce and all that kind of stuff. The berries get more damaged than the dry method, but the wet method is very, very effective when you've got millions and millions of cranberries to harvest. So, listen, I am not a big fan of the sound of this blender working. What I'm going to do is I'm going to take my blender top that has the water and the cranberries in it. I'm going to put it into my little base here, which is electrified, and I'm going to grind and crush all of these berries up until they are a very, very fine thing. And I'll be right back. I'll show you. Hang on. It takes a couple minutes to grind up these cranberries. They're very fibrous, and it takes a long, long time for even a sharp blender like this to grind up all those whole berries into this fine kind of pinkish red soup that they formed. The longer you grind them, the darker the watery, soupy cranberry mess becomes, and that's a good thing. So the next step now is to strain out all the fruit pulp that's in here to give us just the juice. So to do that, I'm going to take my little measuring cup here, and I'm going to insert my little strainer into that measuring cup just like so, and I'm going to pour just enough of this soupy mess into the measuring cup to use for today's experiment. I probably have more water in the blender than I really need for the experiment, so I've got extra reserve, and this is makes a good bit, and you can experiment to your heart's content there at home. So all I'm really going to do is pour my soupy mess into that strainer. I don't have to rush. And you can see how thick this stuff is. It takes a while for it to percolate down through that strainer. And all I'm going to do right now is create a glass full of this strained cranberry soup that we can use now for the experiment. So I'll be right back. So our cranberry soup has been strained, and what's left is now this sort of somewhat foamy, somewhat pinky purple juice. There's chemistry in this juice that has the ability to change color, and that's the essence of today's experiment. We can expect that this juice will change color when it comes in contact with other materials. So we're ready to begin. Now we're going to test this juice 4 times. In this scene, we're going to test it 2 ways. Now let's get our materials together. I have 2 clear glasses here, and these will be our first tests. This glass, I'm going to place the juice from our rusty looking lemon. And then in this glass, I'm going to introduce a chemical that I did not state in my original materials, but it's time that we did. It's going to be our good friend, vinegar. Is there anything vinegar can't do? I don't think so. So here we go. Now, starting with the glass on the left, when I squeezed my rusty looking lemon, it didn't really give me a whole lot of juice, but I'm going to use what I have. I'm not sure if that juice is going to be too old for this experiment, and I'm not sure if it's really going to be enough. Now keep in mind, here is the original color of our cranberry juice, that pinky purpley looking color. Now, I should be able to pour some of this juice into the lemon juice glass, and you should be able to see that cranberry juice change color somewhat. Now, it doesn't really look like it's changing color all that much, does it? No, stayed pretty much the same. All right, fine. Now, let's try our second glass. In the second glass, I'm going to pour just a tad bit of that white vinegar. Now, since I have more vinegar to use than I did the lemon juice, I'm going to pour some more vinegar in there. That should do it. That's about half a glass worth. I'm not really measuring this all that much. Now, let me pour some of this cranberry juice in with the vinegar, and let's see what happens. Now, there is a little bit of a difference here. My cranberry juice, the original cranberry juice, looks much like the liquid that's in the lemon glass right now. But if you compare that cranberry juice glass with the vinegar, my vinegar color has become a little bit more orange. It's gone from sort of a darker cranberry color to a lighter orangey color, and that's important. there is a difference between these two glasses now. I've gone from a darker color to a lighter color. And I'm going to put those glasses to the side and we'll see those again here in just shortly. Now the next two materials, one is going to be a liquid and one is going to be dry. Hang on. Moving on to tests 3 and 4, I have my cranberry juice that came straight from the lovely cranberries, and I have two brand new clear glasses here. Now I have a shorter glass just like the others, and I've run out of glasses. So I'm going to just switch to a slightly taller clear glass for test number 4. Now, in this glass, we're going to place 1 or 2 spoonfuls of household baking soda. This is a solid, it's a white powder. I'm not sure how much is going to be necessary, but we'll just go for a nice educated guess and put 2 spoonfuls of baking soda into that particular glass. And let's focus on this one here. I might actually need my spoon to stir in some of that baking soda after I pour my cranberry juice in there. Now already I'm seeing a color change, and I can see sort of a change to dark purple, blue. Some people might even say it has sort of a blackish color to it, but look how much darker it is than it used to be. Let's compare the color now to the color that it just started out as. Here's our original juice, and you can see that it's already changed color. There we go. Test number 3 is with baking soda. Now let's move on to test number 4. This is the one that I sort of dread because although ammonia is a very useful household chemical, I find it disgusting. I find it very dangerous. I think it smells way too much, but it is interesting. And here we go. Now I don't need much ammonia. Ammonia is a very, very powerful chemical. A little bit will do just fine, and thank goodness for that, because it sort of makes me a little anxious to use ammonia in the house. I'm not a big fan of it, but chemically it's a fascinating thing. So here we go. Let's put number 3 to the side. We now have number 4. Again, our cranberry juice is starting out as this red color, and as we pour some into the glass with the ammonia, wow, what a difference that is. Take a look at that. That's really deep. It almost looks like dark grape juice now, okay? So here we go. In the glass on the left, we have baking soda and cranberry juice. The glass on the right, we have ammonia and cranberry juice. Let's take a look at all 4 tests and analyze them and find out what's going on here. So when we created our sort of cranberry soup in the blender, we mixed whole cranberries with water, strained out the chunky bits, and we were left with this sort of colored, cranberry colored liquid. This liquid contains a chemical called anthocyanin. There's a mouthful for you. And anthocyanins are used as what's called a pH indicator. Now, pH stands for potential hydrogen, and that's about as technical as we're going to get today. A pH indicator has the chemical ability to change its color when it comes in contact with certain kinds of materials. Now, this material contains water, and on the pH scale of colors, water is a neutral. Water does not change the color of a pH indicator. So we can actually look at the color of this cranberry pH indicator, and this is our starting point. We're going to compare all 4 of our test colors to this color, because water doesn't change the color of this pH indicator. So here we have this kind of robust cranberry liquid color. Now, if you remember correctly, we tested lemon juice to our anthocyanin pH indicator. And though it didn't change color much, it is a little less cranberry color. It's a little lighter in color than the original cranberry juice. So we have cranberry juice, we have lemon juice, and then over here we had white vinegar. Now white vinegar really got lighter. It got much more orange in color. So we have darkest, a little less dark, and a lot less dark. It just so happens that lemon juice is a mild acid. And whenever an acid comes in contact with the original pH indicator, when it touches this cranberry juice, it becomes lighter in color. Now, vinegar is also an acid, but it's a stronger acid than lemon juice. So if it's a stronger acid, it's going to become much lighter than the cranberry juice over here. So here we have the neutral cranberry juice. We have an acid lemon juice, it changed color, and we have an acid lemon juice, acid vinegar here, and we've changed color. We've gone from bright red to a little less red to an orange color, okay? So here we have a neutral liquid, we have an acid liquid, and we have another acid liquid. Now, let's compare our original color for the cranberry indicator with our other two tests. In this glass, I put baking soda, and we went from a bright red color to quite a dark, almost a plum color. Then we added cranberry indicator to ammonia, and it became deep, deep blue, almost a brown color. So look at the difference. Here we have the neutral pH indicator, and we've gone in the other direction. We've gone darker, and even darker still. It turns out that baking soda here is a base. It is a base, so the pH indicator is going to turn dark blue when it touches a base. Well, baking soda is sort of a mild base. Ammonia is a strong base. You can tell by the way it smells. So we've gone from bright red neutral to darker blue base to almost a deep brown base with the ammonia. Ammonia is a stronger base than the baking soda, so the ammonia becomes even darker. And listen, this is a great experiment. You can experiment with the original pH indicator with all kinds of substances at home to test whether they're a neutral, whether they're an acid, or whether they're a base. Just be safe if you're using harsh chemicals like ammonia. Please, 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 everybody. So listen, if you have questions, we'll take your questions now in class. If you want to send me your questions, we can have a discussion about pH and pH indicators. I hope you had fun today. Kumbaya to everybody, and we'll see you next time on McCall Science Enrichment. Take care, everybody, and we'll see you soon. Bye-bye.